Deeper down the rabbit hole we go with VLANs as we unpack VTP and 802.1q. In the last nugget, I gave you kind of the overview. Like, this is what VLANs are. This is why they're great. This is some examples of how we can use them. Now I'd like to unpack the details of it. So how to look at trunks and how they really work, and that there's really a secret sauce behind them called 802.1q. We'll look at a concept of the native VLAN, and then finally look at VTP, how it can help or destroy your entire network. Okay, let's pull a little review from the last nugget. Trunking, what is it? Well, trunking is the ability to connect multiple switches together and allow your VLANs to seamlessly go across your entire campus fabric. Man, that statement was made for a marketing magazine or something like that. That sounded so good, I couldn't even say it again if I tried. But if I connect multiple switches together, like let's add switch C and switch D together, well, it gives me the ability to add computers and devices and wireless access points and printers and whatever else, whatever widgets I'd like to, all around the campus, and allows these VLANs to span that direction. So, for instance, let's say VLAN 2, which I have there is that little orangish computer. VLAN 2 might be the sales VLAN. So all the salespeople are a member of that. So I can now add salespeople down here and add them as well to VLAN 2. And maybe this wireless access point is actually for VLAN 3 because only the executive team get wireless access or whatever. You get the point. We can stretch our VLANs all around our company through this concept of trunking. Now what trunking does is tag. Remember I said in the last nugget, a better word for it is tagging. Tag each packet that's sent across the wire, across those links that connect the switches, with this special little 4-byte field. Now, there are two forms of trunking. One is 802.1q. I'm hesitant to even say this nowadays, but you may see it. You may encounter it somewhere, sometime, whether it be exam, whether it be real world, you might run into it. There is another one called ISL, Inner Switch Link. So these are two different languages that you can use for tagging packets. Now, Cisco was first to the game with VLAN. Long before there was a real standard, or at least I should say a good standard, Cisco came out with something called Inner Switch Link. Now that worked, and it allowed you to tag your packets with specific VLAN information and send it across. But anytime you say Cisco made it, that means it only works for Cisco switches. 802.1q, which was the eventual standard, is the replacement for ISL. Now, this is industry standard. Well, you get the point. Industry standard to where any vendor can create a switch and use 802.1q. So I could, I've got switch A, which might be a Cisco, maybe bring in switch F over here with it's some heathen brand over here. We don't know, but as long as it's a managed switch, it will support 802.1q and it will do VLANs and now be able to integrate and speak that trunking language with my Cisco switches. So let's dig a little bit deeper. Inside of this little 4-byte tag is VLAN data, and this is where it will be one of 4,096 different values to let it know which VLAN it belongs to. And then next to that is something known as the priority, or if you dig a little bit deeper, it's not part of this series, but that is actually called class of service. So switches can do quality of service as well. So I can put in this header information, I can put little tags that say, ooh, this traffic's really important. You're a level 5 traffic. Whereas this traffic, it's not that important. You're a level 1 or level 0 traffic. So these are all known as the COS, or class of service bits. If you ever decide to dive into CCNP or get into voice over IP or one of the more advanced tracks, they'll totally explain that. For now, we don't care. All eyes are on that VLAN tag, which is sitting in the header, and it passes all of that between switches by embedding it into each frame. Now keep in mind, this is a trunking thing. This is only on the links between your switches. VLAN tags are always removed when we're sending data to the computers themselves. Partnered with the concept of trunking is the idea of the native VLAN. Trunks send tagged information, right? Let me go with the simple view here. We got a couple switches. Let's say we've got 3 computers up here that are all, these guys are a member of VLAN 2. This guy's a member of VLAN 3. And then down here, I've got one computer that's a member of VLAN 2 and one computer member of VLAN 3. So if this is a trunk, it's going to send tagged information across. So as VLAN 3 sends a broadcast, it will come down here and go, oh, let's put a little shim on the header there. We've got VLAN 3 tag. That's now we officially know an 802.1q tag on that header. So when this guy gets it, he goes, oh, you belong to VLAN 3, strips off that little tag, and then sends it to all the VLAN 3 devices. That's what trunks do. Now, the question of this native VLAN comes in when we say, well, what if I need to send something between these guys that is not tagged? Now you might look at the picture and say, well, look at the picture, what wouldn't be tagged? I mean, we've got 2 over here and 2 over here and 3 over here and 3 over here. So you would have tags of 2 and tags of 3 going over. Why would you send something that's not tagged? Well, there are management protocols that run behind the scenes on switches. Like one of them we know is Telnet. Another one might be SSH. So maybe I'm sitting here plugged into the console port of this switch. This switch is 300 feet down the hall, and I'm like, well, I don't want to go walk down the hall with my laptop. That's a far walk. I'm sitting in my chair. I'm kind of cozy. I just want to telnet from this switch down to this switch, right? Well, if I'm telnetting from this switch to this switch, what VLAN does that belong on? Well, none. Really. I mean, it's whatever VLAN this switch management interface is on, which is probably VLAN 1. So it's going to send that across untagged. Or there's another protocol we haven't talked about yet called CDP. It's a discovery protocol. It's kind of neat because Cisco devices will send each other these little discovery messages where they're like, ooh, I see you, my little friend, Cisco device. I'm going to add you to a table. So an administrator at any point can type in a command called show CDP neighbors, and they can see all the Cisco devices around them, all of the devices that are attached to whatever device they're on. Well, in order for CDP to work, these guys have to send like little probes, little hellos saying, hey, I'm running CDP. This is me. I'm a switch. Did you know who all of that stuff is running on the native VLAN. It doesn't really belong to a VLAN so much as it's just traffic that needs to pass from one switch to another. It's considered untagged traffic. This concept originally came about in long ago when switches were so expensive, people were like, man, we can't afford many of these things. Let's put hubs in the middle of our network so that we can kind of balance the cost. So we would have some switches going through hubs to reach other switches. Well, on those hubs, we would plug in computers. And these switches would have trunks to each other. They'd be tagging packets, so VLAN 15 ends up on VLAN 15 and all that kind of stuff. But the question became, well, what happens when this computer comes in on that port and says, hey, I want to talk to something? What VLAN is it on? The native VLAN. If a trunk receives data that does not have a tag on it, it will automatically become part of the native VLAN. Nowadays, burn that model. Nobody does that anymore. That's like, that's heresy. Why would you put a hub in the middle of your network? But nowadays, we use this concept for things like this. For example, best practice says, I want to put my IP phones on a VLAN. Let's put them on VLAN 15, which is separate from the computer that it's plugged into. Maybe this guy's on VLAN 10. Why is that a best practice? Because it's scary. If you have your computer and your phone on the same VLAN and somebody pulls out Wireshark, Wireshark has the ability to capture voice packets and reassemble them into audio files. So back in the day, people would have those little butt sets that they would have on their waist with the alligator clips, that they would clip onto the wires and be able to kind of tap phone conversations and hear what's going on. I mean, phone techs still have them today. I shouldn't say back in the day. They're still around. Now you can do that without needing any alligator clips. You can open Wireshark and capture the data. So Cisco's like, whoa, let's keep this guy on a separate VLAN than this guy. But then we run into the problem. Well, how do you do that? Because normal ports are only a member of one VLAN. And then, if this guy is sending traffic, how do I differentiate between him sending traffic and him because they're coming in the same port? Well, that was where that concept of the native VLAN came in. Now what I'm about to tell you is, if you were to tell this to Cisco, they'd be like, no, that's not how we do it. It's not, because it's actually a security flaw, if you will. But it was the original way they do it, and it's still kind of the way they do it. But let me explain, and then we can unpack all of the politics behind it later. The way that we can make this work is to configure this port as a type of trunk. Now, a trunk will send tagged packets, which IP phones understand. So I can say, on this trunk, I'm going to have VLAN 15 be the tagged VLAN. Now, that's good because this phone understands tags. Cisco IP phones, you pull them out of the box, they're like, I speak the language of 802.1q. I speak tags. So as I'm speaking on the phone, I'm saying, hello, everybody, on the phone. It's sending packets, and it's automatically putting them with a little tag of 15. So the switch goes, oh, okay, you're coming from a phone. I'm going to put you on VLAN 15. Now, the computer, no idea what a VLAN even is. Computers do not know the concept of VLANs. They know the concept of surfing the web. They know the concept of transferring files. So if they just have an IP address, they're just sending data. So they're coming in without any VLAN tags. That rings a bell. If they don't have any VLAN tags, then what are they on? The native VLAN. So what you would configure this for is it would be a trunk, and I would set it up for a native VLAN of 10. So when this computer starts sending data, it doesn't have a tag. It says, well, you must be on VLAN 10. So that's kind of how we apply that concept today. Now, Cisco has new and improved ways of doing this kind of thing. So the reason I emphasize that is because they really make a point of saying it's not a trunk. It's a tagged access port, but it really is kind of the same thing. So for now, just for the concept, that's what the native VLAN is all about. So why am I talking about this? It's kind of like, okay, good, I get it. What's the point? Well, the point, I found out. So this has been bugging me for so long. You see how my circles are kind of like blobby? See that? I found out that my little drawing program here converts when I clear it like that, when I clear it converts my pen to like a gel pen. And I finally figured out, check this out. Watch the blobby. Watch it. Bam. Isn't that so much cleaner? Oh, come on. The difference, gel pen, ooh, ugly. Default, ooh, that much better. So I finally figured it out. I was very excited. But why am I telling you this concept of the native VLAN? The reason why is because it's dangerous if you mismatch them. So what I mean is this. Let's say we've got two switches, and by default, the native VLAN is 1. That's just how it is. But you can change that. Let's say on one side I make the native VLAN 10, and on the other side I make the native VLAN 20. Right? Well, that poses a problem. It's going to break something, likely, if I do that. The switches will start yelling at you. They'll send you messages on the console port like mad, being like, native VLAN mismatch, don't do this, something is very wrong. But what ends up happening is devices that are on VLAN 10, maybe they're the accounting devices, and devices that are on VLAN 20, maybe they're the sales devices, end up merging together into this big blob VLAN. So here's what happens. This guy sends some data to the other side. The switch is like, oh, okay, you're trying to reach, we'll say, device X over here. He's in VLAN 20. But as soon as it hits that trunk port, it goes, oh, wait a sec. VLAN 20 is my native VLAN. That means VLAN 20 doesn't have any tags. There's no tags on there. So rather than doing what trunks normally do, which is stick a little tag on that packet saying VLAN 20 is tagged on here, so this switch gets it and he's like, oh, you belong to VLAN 20. He goes, oh, well, that's my native VLAN, so I'm going to strip the tag off. There's going to be no tag. I'm just going to send it untagged, because remember, native VLAN equals untagged. So on the other side, I've got a native VLAN of 10, so it comes in and it assumes that I'm on VLAN 10. So this untagged traffic went out on 20, came in, it's like, oh, well, my native VLAN is 10, so now I'm on 10. Is it supposed to do that? No, but it's how it's configured. That's called the native VLAN mismatch. And what it does is undo a lot of your security boundaries to where this guy can now get to this guy, and he's not supposed to. Because and same thing happens on this side. If I've got a computer in VLAN 10 over here, when he sends it, he's going to be like, "Oh, VLAN 10, that's my native." So I'll send it untagged, and it comes in on this guy's VLAN 20. So my point is, if you're configuring trunks, which we're going to do in the next nugget, you want to make sure that the native VLAN matches between both sides. Now let's get back to Cisco. Cisco had a really good idea. Remember I said they were first to the game with VLANs. They came out with this protocol called ISL. We don't use it anymore nowadays, but it was great for its time. Well, way back then, Cisco, was kind of looking at the VLAN standard as it was emerging, and they're like, we can do something really cool. We're going to come up with this protocol called VTP. Now, first off, the name will mess you up. It stands for the VLAN Trunking Protocol. But, and I'm gonna say it, and I'm gonna say it twice because I want it to stick in your head. It is not a trunking protocol. Okay, get it? The VLAN Trunking Protocol is not a trunking protocol. There are only two trunking protocols out there. One of them has gone away. One is ISL. The other is 802.1q. Those are the two those are the two protocols that can tag traffic so that switches know what VLAN it belongs to. That's it. So the VLAN trunking protocol, is not a trunking protocol. It should have been called the VLAN replication protocol. That's my humble opinion. But nonetheless, here's what Cisco's goal was, and it really was a good idea. You know when I'm saying this that I'm going to have this kicker at the end that I'm like, yeah, and it's not a good idea anymore, and you're right. So VTP was a great idea because what would happen is it would save you configuration work and make your network totally consistent. So the way VTP works is you would link up all your switches with trunks. So we've got 802.1q running everywhere here. This is our trunking, right? 802.1q trunk. That bridged all our switches together. And I would go in and I would create a VLAN. Let's say VLAN 10, and I name it. That's one of the things you can do. We'll say name sales. Now VTP immediately goes, oh, I'm gonna update my database. It looks like they made a change. All the switches, by the way, start their database at revision 0. So it's a revision 0. It now goes, okay, they made a change. They added VLAN 10. We are at Rev 1. He sends an announcement saying Rev 1. This guy's like, oh, sweet, Rev 1. I want Rev 1. Rev 1, Rev 1. So all these switches are getting this little revision, and they go, well, what's to be revised? My VLAN database. So they all have VLAN 10, VLAN 10. So it saves you the time because normally I have to go switch by switch by switch and add in VLAN 10 and add in and name it and give it a name. I mean, I know I'm making it sound like a lot of work, and it kind of is, but VTP just makes it that much easier. And then I go in there and I say, well, I'm going to add VLAN 20. Maybe VLAN 20 is marketing. And it goes, okay, Rev 2, Rev 2, Rev 2, Rev 2. I mean, it's almost instantaneous. It's like snap your fingers, bam, VLAN 20 appears on all the switches. And now all you have to do is start assigning the ports to it. So it knows which ports belong in which VLANs. But it saves you a big part of your configuration. So that's really cool. Here's where the problem comes in. I'm talking about all this, right? Let's say that you go out on eBay. After this discussion, you're like, I got to do this. I'm going to go on eBay. I'm going to buy a switch. You look at the description. It says, Cisco 3550. The company went out of business. Used it for 8 years. Still works great. Their loss, your gain. Buy it now, $50. And you're like, oh, $50. What a great. So you buy it now. Bam. You get this switch in the mail. You go to log on, and you find out it has the company's old configuration on it. That's cool because it's very easy to do password recovery on a Cisco switch, and I love when I get stuff off eBay where it has old configurations because I like seeing how people's networks are set up. I'm like, ooh, and I just like seeing that. So you kind of you look at it, you're like, man, this is really cool. Oh well, okay, let's erase it. So you erase the configuration on the switch. You do write erase is one of the ways to do it, quick way. Reboot. Okay, I'm back to a clean config. Okay, I'm playing around at home, doing my thing, right? And all of a sudden I'm like, oh, I got to go to work. And then the thought hits your mind. You know what? I have a lot of downtime at work. Maybe I can bring my switch to work that I got off eBay and just do a little studying. And so you're like, that's a great idea. So you bring your switch to work and you're configuring. You're like, man, this is great. And all of a sudden it hits you again. You're like, well, you know what? I've got this home switch. Poof. Enter the picture. And I've been playing around, but I want this to be real. Here's what I want to do. I want to take my cubicle here, and I've got this little wall jack, and I'm gonna unplug my computer that's plugged in. I'm gonna plug it into my home switch, and you click it in there, and you. If it were a made-for-TV movie, it would be slow motion. There would be some guy jumping over the cubicle, going no, there'd be some drama here. But for now, you just click it in. Light goes green, and all of a sudden, poof. First thing you notice, first thing anybody notices is you'll see a head poke up in the cubicle farms, and Bob down the hall is like, "Hey, is your email up?" Someone else is like, "No, my Facebook access isn't up either." Like people immediately notice email and Facebook going down, and you're kind of like, "Ooh, yeah," and you kind of unplay it and shove the switch in the drawer. What happened? Well, what happened was you got this switch from company X on eBay, where they'd been using it for 8 years, and they'd probably made a bajillion VLAN changes. Deleting VLANs, adding VLANs, all that kind of stuff over the years. Maybe they're up to VTP Rev 302. And maybe that switch on there had VLAN 100. That was the only VLAN, at this point, because you were playing with it in your lab or whatever. That's the only VLAN that you had. Well, as soon as you connected it to that wall jack, it goes through the ceiling and eventually connects back here. This guy's like, "Hey, buddy, I've got VTP Rev 1302. Your corporate switch is like, "Great, I'm at 2." He's like, "You're way better." So the way VTP works is it's not like let's talk, let's kind of merge our VLANs together. No, that's not how it works. He's like, 1302 says there is no VLAN 20. 1302 says there is no VLAN 10. 1302 has told me the only VLAN that there is VLAN 100. And like I said, it's very fast. Bam, bam. All your VLANs are gone in your entire enterprise, all replaced by VLAN 100. You know what that looks like? You walk into the IT room and you see the switches, and they've all turned amber. Every light on them totally has gone from green and flicking and happy to this amber, like death-like state. And usually the IT person passes out when they see it because the entire network is down. What has happened is it eliminated VLANs 10 and 20, but all the ports are assigned to those. So it's not like the ports are like, "Oh, well, I guess our VLAN went away. Let's all go over to VLAN 100 now." No, they don't do that. They're like, "No, I'm still in VLAN 20, and VLAN 20 doesn't exist, so I'm going to turn myself off. I'm going to put myself in a disabled state." So essentially, your entire network goes down. Now I know what you might be thinking. You're like, "But wait a sec, didn't you say I erased the switch?" If you're speaking for my life, didn't you tell me that I erased the switch before I bring it in? Yes, I did. Because VTP revisions survive configuration resets. VLANs survive configuration resets. So this little story could happen. But now let me add in a little reality to it. Well, first off, it has happened a lot. It completely takes down the network, and the problem is, people. First off, it takes somebody some time to figure out what's happening. I mean, you walk in, the entire thing's down. You're not thinking, "Oh, my VLANs must be gone." You're thinking virus, worm, outbreak, failure. You're on the phone. You're like, "What do I do?" You're not even thinking straight when something like this occurs. I mean, everybody's yelling. Companies like, "We're sending everybody home for the day." Losses, all it's not good. So this is one of those not good days. So by the time you finally do figure out, you're like, "Oh man, my VLANs are gone." A common fix is you take a switch off, you restore the configuration from backup. You're like, "Okay, well, let's put the old VLANs back on," and you reconnect it. Well, what happens as soon as you reconnect? Bam, revision 1302 comes and destroys you and deletes your VLAN again. The only way that you're going to get it back is to manually add your VLANs back in. So you go, "Okay, VLAN 10 exists. Now we're up to Rev 1303, and now that replicates up. VLAN 20 exists, 1304, and we start getting our VTP revs back up. So now let me add in now a little protection. The way VTP works is through a common domain name. A lot of companies make it their company name, like Intel. They'll have the VTP domain Intel. So if this guy comes in and doesn't have the same VTP domain name as the rest of the switches, then his revision will be ignored. So I know you're kind of like, oh, okay, well that's a little better. Well, here's where it usually happens. This, by the way, VTP outages are they are common. If give me a group of 10 Cisco people that have worked for 10 to 15 years in the field, and I guarantee you probably 2 or 3 of them have seen a complete network takedown from VTP. So where it usually happens is in a lab environment. You got the company lab, right, where the company buys some stuff for people to play with so that they can do testing, they can do experiment without messing with the production environment. Well, what ends up happening is there's a switch in the lab that seems to be totally functional, totally fine, that we've just been playing with for a long time. In a crisis, the company's like, oh man, we're out of switches and we just hired 3 more people. Do we have any spares anywhere? Again, made for TV movie, slow motion music comes as somebody walks in the lab and brings out this lab switch, which has a higher VTP rev than the corporate network and happens to mirror the config in many ways as the corporate network, but maybe doesn't have the same VLAN numbers, and click. That's where it wipes out the entire network. So that's VTP. It's kind of like, yeah, that was a cool idea, but I will tell you, Cisco now, they have changed their recommendation. Cisco will tell you in big, bold, red letters, don't use it. Despite Cisco's recommendations, many people still do use VTP because it is really handy. And as long as you are very careful, it works well. Like I said, for every 10 Cisco people, there's 2 or 3 of them that have seen a complete network outage, but that means there's 7 or 8 of them that are like, it's totally fine. So when you are using VTP, there are 3 modes that it can be in. A Cisco switch can be a VTP server, which is the default. When you pull it out of the box, every Cisco switch is a VTP server. And that means it has the power to create VLANs, to delete VLANs, to rename VLANs. It can do all that stuff and then send the updates to all the other servers. Now, you can have all your switches be servers if you want to, and that just means you can change your VLAN configuration from any switch. Now, if you are going to use VTP, what Cisco recommends is saying you have one server, meaning one place that you can change VLANs from, and all the rest of them are configured as clients. So the client switches, you can't update VLANs. They will only accept updates and send updates. If for instance, there's a server down here or something like that, he'll accept updates and he'll send updates to the other switches. But you can't go in there and change VLANs, delete VLANs. If you try to, if you log onto that switch and you're like, okay, add VLAN 20, it's gonna be like, sorry, you're a VTP client, you can't do that. Now you might be like, well, this seems safe. How can that cause problems? Well, a lot of times we are our own worst enemies, right? Because you log in to that client switch and you're like, oh man, I got to add VLAN 20, and you get the message, I'm sorry, this is a VTP client. You're like, well, buddy, it's one command. No, you're not. You're a server. You type in literally the command is VTP mode server, and poof, now I can add my VLAN without trying to figure out where in the network my VTP server is. So good intention, but a lot of times our own self-discipline gets away from us. Transparent mode. Now, the Cisco recommended mode. VTP transparent mode essentially means I am not using VTP. Truth be told, the way Cisco switches work is there is no way to, and I'll put it in quotes, turn off VTP. Like you can't go in there and say no VTP and stop running it, but you can go in and say I'm running VTP transparent mode. And what that means is now every single switch, if it's transparent, every switch can change VLANs, it can modify VLANs, it can delete VLANs, it can do whatever we want, but I'm not ever going to tell that VLAN information to anybody else. Meaning I'm not really participating. Now, if somebody sends me a VTP update, if maybe somebody else is running VTP, I'll be like, hey, thanks. I'll forward that on to any other switches that need it. But you know what? I'm not looking at it. I'm a transparent switch. Think of the words. I'm transparent. I don't exist to you. Or we can add some movie drama. I'm dead to you. All the switches that are transparent, totally ignore it. But it is worthwhile knowing, like if I have a VTP server here and a VTP server here and he's sending an update, the transparent switch will ignore it and yet still pass it over to that server. One more neat feature associated with VTP. It's the concept of VLAN pruning. What this allows you to do is stop VLANs from crossing links where they don't belong. So let's say you've got this environment and set it up with 3 switches. You create 3 VLANs. We'll just for now call them VLAN green, VLAN blue, and VLAN red, which match up to some number. So those are all created. Those using VTP automatically replicate and now appear on all the switches. However, on this bottom switch, you only assign computers to the red and blue VLAN. You don't assign anything to the green VLAN. Well, what VTP will do is have this switch report back and say, hey, green VLAN, we don't need it here. There's no ports that belong here. So this switch, automatically prunes green traffic from coming down here. So if a green computer sends a broadcast, that will come down here, but then stop. It doesn't continue on, and like you see right here, stops all the unnecessary broadcast traffic from crossing the links. Well, that's great, but here's the funny thing. Cisco, with their design, they're like, yeah, you should have one server and then multiple clients. Well, VTP pruning only works if you have all VTP servers. Like if this guy's a VTP client, he won't participate in VTP pruning. So a little ironic with the design there. Now some of you might be thinking, well, if we can't use VTP to do this, then how do we do it? Manually. You go back to the manual model. That's how everybody else does it. You go to every switch that needs the VLAN. You manually create it. You manually add it to the trunk, and that's okay. I mean, if everything was auto, we wouldn't really be paid for anything. And I will tell you, and this is kind of a rule in general, with anything auto in network technology, the mantra is you auto, not use it. Because it leaves too much to chance. Anything that it's kind of like, oh, don't worry, it just kind of figures it out for you. I'm always like, really? All the time, every time, 100% of the time, it figures it out for me? I'd feel better. I would just feel better if I could say, okay, that trunk has this, and this VLAN. That would just make me feel better to manually type that in because, again, it's not that much work and it impacts so much. So I would love for it to come back and say, okay, if it's working, I look at it, I'm like, that's good. It's all me. I know exactly. That sounded bad. It's all me. Yeah. But no, if it's working, I'm like, no, I know exactly what that config is. I have backups to the config. I know what it looks like. It's not just like, well, it just kind of happened. They just kind of figured it out. And then if something goes wrong, I'm like, what's going wrong? What auto mechanism did this to me? So that's the overview of why we don't use VTP anymore. So to summarize, we saw in this nugget how the trunks really work, and that's using that 802.1q protocol, industry standard protocol that works VLANs across the board. We saw the VLAN lingo of native VLAN, so we know what that concept is. It's essentially the untagged VLAN, or the untagged, I should say, number when we're working on trunks. My little lines weren't connecting there. When we're working on trunks, if I send something without a tag, it belongs on that native VLAN. And then, of course, we discussed VTP in all its glory. I hope this has been informative for you, and I'd like to thank you for viewing.